Okay, let's continue with paper 2, YTSS 201 for Prelim. Okay, the first question is on kinematics. So just a quick revision, this is a velocity time graph. So you need to know that on a VT graph, you can get a lot of useful information. Firstly, the gradient of a VT graph would give you the acceleration and also the area under the VT line would give you the displacement, which is denoted by S. Okay, so another common mistake that students make is that they are careless when reading the coordinates. So what I suggest you to do is that write down the coordinate of the points on the graph itself. So for example, this is 20, 30, you read from the X, then the Y. So to calculate the acceleration, you just need to find the gradient, use the correct coordinate, and the formula, you'll be able to find it. Now, then after that, they ask you for same velocity. So since this is a velocity time graph, you just need to read, okay, where this A line and B line intersect. So it is this point whereby B is having the same velocity as A, which is 20 meters per second. But since the question is asking for the time, you need to read this point and read down to the x-axis, which is 30 seconds. So you get the unit from the unit of the axis label. Then after that, they ask you to find the distance. Basically, it's the area under the line. So in this case, it is triangle. So just use the triangle formula, you'll be able to get it. Then after that, you're supposed to find the distance of the time when they are both having the same velocity. So since we have already determined that this is the point whereby they are both having the same velocity, what you need to do is that you need to find the area under the B line, which is essentially a triangle, and then the area under the A line until this point. So you can break this shape into two. First, you will get a triangle, which is here. Then after that, you have to find this trapezium. Okay, so this is how you get it. At time equals to 30, area under A is the triangle plus the trapezium. You get 550. Then the area under B is basically what you get from part C. So minus them and you will get, subtract them from each other and you will get 250. Okay, for question 2, it is on dynamic. You need to be careful on, again, the second law. It is about the net force. Okay, so in this case, you are asked to find the resultant force. So if you look here, they tell you that this block, okay, there's a printing error here. The line is supposed to be at the bottom. So they didn't tell you really whether there is friction or not, but they gave you the acceleration value. So just use your Newton's second law, plug in this 2 meters per second square here, and you'll be able to find the net force, which is 14 Newton. Okay, so explain why the resultant force is less than the applied force. So they're asking you, why is this value smaller than this 20 Newton that is pulling to the right? Okay, and the reason is because there is actually a frictional force, which is not shown here, acting towards the other side, and that's the only reason why you will get resultant force that is less than your forward pulling force. Okay, so you have to explain that the net force is actually the applied force, which is 20, and you have to minus off whatever force that is opposing the forward motion, which in this case is friction, but I didn't state it here. So you have to say that there's an opposing force acting against the applied force. Okay, and you can be more specific. The applied force is the 20 Newton. Okay, so that's why. Okay. Okay, then for the third question is on pressure. It's basically a hydraulic jack. Okay, it works on two principles. Number one, the pressure of A must be equals to the pressure of B because this is an enclosed system. So the pressure at every point in this liquid will be the same. So the pressure here and the pressure here must be the same. Another principle, the second principle that is being applied in this hydraulic jack is that the total energy at A must be equals to the total energy at B, the conservation of energy. So using these two principles, you should be able to solve this entire question. Okay, so for part A, you are asked to explain why is liquid incompressible using the kinetic model of matter. Okay, and it is you have to say two things. Number one is it is closely packed structure, and number two is that because of this closely packed structure, there is little space in between the particles. That's why you can't squeeze them closer to each other, making them incompressible. Okay, then one thing to take note, it is not the particle that is being squeezed, it's the space in between the particles. So this is one of the common mistakes that I see among students. Okay, then for your part B, you are asked to find the pressure. So P equals to F over A, the F is given, the A is given, make sure the units are correct. This must be in meter square, this must be in Newton. So once you do that, you'll be able to find it. Okay, so this is round off to 3SF. And then you are asked to find the force exerted on piston B, and you can use the concept that I just mentioned. Pressure A must be equal to pressure B. So since you have already found pressure A, you can directly use this value on the left hand side. So on the right hand side, the pressure B can be expressed as the force at B acting over the contact area of B. So once you do that, move your AB to this side. The area of B is given as 0.65. Do the calculation, you'll be able to get the force. So what you are seeing here is that how the hydraulic jack works is that you see the force at A is only 50 Newton, but the output force at B becomes almost 2.17 kilonewton. That is about 2,000 Newton. So you see that is really a big change in the force. Input 50, you get almost 2,000 Newton at the output. Okay, question 4 is about energy conservation. So you are given a sphere and it is rolling along this path and all that. So when you are doing the energy conservation kind of question, you must determine a reference point. So my reference point is the start here. So this is my initial position. So at my initial position, it will have definitely some PE and KE. So since in this case, the initial speed of the sphere is 0, my initial KE must be 0. But my P here will be given by mgh, which is 0.8. So this will give me my energy total initial. Okay, this is my initial total energy. And this initial total energy will be the same at every point along this path, okay, unless there is some energy loss. So this is what I mean by energy conservation, that the total energy is the same throughout the whole path unless you have energy loss, could be due to friction and all that. But in this case, the question already says there's no frictional force. Okay, let's go into the question. So part A, you are asked about the gravitational potential energy at S. So what you need to do is what I stated here, P equals mgh, substitute the value in, make sure that this is in kg, this is in meter, you'll be able to get, remember the unit here is joules. Okay, then after that, calculate the gravitational position energy at position C, and hence means that I have to use the answer that I get, okay, for the first part and determine the KE. So this is pretty simple. So let's look at the diagram again. So at point C, my H becomes 0.6, meaning that my PSC would have changed to some value which is definitely less than this value, meaning that I will have some KE here. So what I mean is that I need to find out the PE here and the KE here, and the sum of this must be equals to the energy total, meaning that these two must be the same because we are assuming no energy loss. So let's go into the calculation. So PSC is mgh, so the H here is 0.6. So that's why I put 0.6 here is 1.8. So I know that the total energy must be equals to the sum of these two, and I know that from the initial position, the energy total is 2.4 joules, which I get from here. Because at the initial position, there's only PE. So that's why it is 2.4. Okay, it must be equals to 1.8 plus some unknown amount of KE. So once I do the subtraction, I will be able to determine that my KE at C is 0.6. Okay, so part C state at which point whereby the speed will be the maximum. So since if you look at the equation here, that the total energy is equals to PE plus KE, ideally, if you just want the higher speed, you would want the PE to be 0 so that all the energy will be converted into KE, which will give you the maximum speed. Okay, you want PE as low as possible. So if you look at this diagram, you will see that the lowest height, which will give you the lowest PE, is at A, 0.3. So down here, you just need to say that it is at A, it will give you the maximum speed, and you have to explain. So first state that at A it is the lowest point, and hence the PE at A is lowest. So since you can quote the formula that KE is equals to the total amount of energy minus of the PE, KE will be highest at A. Yeah. Okay, question 5. Okay, question 5, you are asked to draw the cooling, is it cooling curve? Oh, it's a heating curve, so it is heating. Sketch in the thing. Okay, so you are asked to sketch. So when you sketch, it is important that you label your axis. So usually it is the temperature, okay, state the unit is against the time. So make sure you also state the unit. Okay. So the substance is going to be heated from 50 degrees C. So therefore you need to have the lowest point at 50. So you're going to start out here. Okay, and as it heat, it will start to melt at minus 25. So you know that, okay, you heat something, it will start to melt. So you know that during melting, the temperature is going to constant. So I'm going to draw this line first. It's going to melt until some time that I do not know, so just put a point first. Okay, then it's going to increase all the way until I hit 50 degrees C. So because they asked me to draw to scale, so 50 should be around somewhere here. So I label it 50. Okay, it's going to hit all the way until 50. So let's say I give it an arbitrary point, just like that. And I know that for it to boil, it will take a longer time than melting because boiling takes more energy. So my constant temperature line should be longer. Okay, and then it's going to heat until 75, right? So I must end somewhere here. So now I just need to draw my curve. Okay, at secondary school, you are not penalized whether you have drawn the right, you know, about the gradient, whether it's a straight line or a curve. So I will just draw a curve. I will just draw a straight line, sorry. Okay, so straight line here, 50 reaches 25, is going to melt, that's why constant temperature. After it has completely melted, it's going to get heated up again. Okay, and then after that it's going to boil at constant temperature, and finally it reaches the 75 degrees C. So as you can see, it is not that difficult to draw the heating curve. Okay, you just need to, you know, plot some points. You need to know that during melting it must be a flat line, during boiling it must be a flat line, and then after that you just join all the points together. Okay, describe the state of matter at 30. So since 30 degrees C is in between the melting point and the boiling point, so you would know that the 30 degrees C will give you liquid. Okay,